Today we're going to learn how to use the logic that we've picked up in our last lesson or two for this unit. We're going to learn how to use that logic and illustrate it in Venn diagrams. So you can write your essential question now, or we can do the lesson and then you can go back and put it in at the end. So let's just start with some examples. We talked about the little two-circle types of Venn diagrams already. And if you remember, we said that our hypothesis, I'll draw this up here, our hypothesis is always in the little circle and our conclusion will always be the big circle. So let's do a couple of little easy examples here. So it says if a polygon has 8 sides, then it is an octagon. So in here we know we've got the polygon with 8 sides. And it is an octagon. Okay, although I have a little trouble deciding why that wouldn't be okay either way. If a polygon has 8 sides, then it is an octagon. If a polygon is an octagon, then it has 8 sides, because I don't think there are any polygons that have 8 sides that aren't octagons. So I really think that Venn diagram would have been okay either way. Which means what? It means the converse and conditional are true, and therefore I could write it as a you-know-what, a biconditional. So I think I could have put octagon here and polygon with 8 sides here. Because those are really the same thing. How about this one? Maybe it works both ways too. If an angle measures 80 degrees, then the angle is an acute angle. So if our hypothesis goes totally inside, then we have an angle measures 80 degrees, and then it is an acute angle. So what do you think? Can I do that one either way? Could I write this one as if an angle is an acute angle, then it measures 80 degrees? I don't think so. Why? Because all acute angles don't measure 80 degrees. This scenario right here says that every single acute angle measures 80 degrees, so that one definitely does not work. So there's a case where we couldn't write a biconditional because the converse is not true. How about this? I go to the grocery store only on Saturdays. Oh, this is an interesting one. So you might want to, how about you take a moment, pause here, like I asked you to, try to write the conditional statement and then fill in your Venn diagram and check back and see if we did it the same. Okay, here's how I did it. If I go to the grocery store, then it is Saturday. So I'm betting that a few of you may have written, if I go to the store, no, I'm sorry, if it is Saturday, then I go to the store. Now, think about that for a minute. The reason that doesn't work is because the statement says, I go to the store only on Saturdays. So if it's any other day of the week, I'm not going to the store. However, there are other things I'm going to do on Saturday besides go to the store. So if I drew this way, if I put Saturday here and I put going to the grocery store here, then this Venn diagram that I have just drawn here is saying that on Saturday, all I do is go to the grocery, no, I'm sorry. Yeah, on Saturday, all I do is go to the grocery store, but that's not what is being said in my original statement here. So just like last time, when we were writing biconditional statements to represent the given statement, we have to be very careful how we represent these statements so our Venn diagram says what the statement says. So this is the one that you want to have here. If I go to the grocery store, then it is Saturday. Not, the incorrect conditional statement would say, if it is Saturday, then I go to the grocery store. okay, because I might be doing something else on Saturday. There are many other things I can do on Saturday in addition to going to the grocery store. All you know is if you see me at the store, then it's definitely Saturday. All right. Oh, now you get to make up your own. So you can do this now or you can do this after the lesson. I'll just write you down here what I did. And I wrote a conditional statement. I'll actually pause here and write my statement so that it shortens your video time just a little bit. So I'll be back in a second. Okay, for this first Venn diagram, my conditional statement that I wrote says, if I go to bed early, then I will feel good tomorrow. All right, so of course, going to bed early, if I go to bed early, then I will certainly feel good tomorrow. Okay, if I put the feel good tomorrow inside, it would say if I feel good tomorrow, then I went to bed early. Well, that's not the same statement and it's not necessarily true. All right, I could feel good even if I don't go to bed early. So you've got to be sure that your Venn diagram represents the statement. Okay, and what you see here is I have an and. You see this part here, our Venn diagrams, where they overlap, that is an and statement. That's what happens when both of those two come together. We know that as the intersection, right? The intersection. Intersection means and. So if I am a runner and I do yoga, then I will be in good shape. So all this area right here are the people who do yoga and run, and those people are in good shape. All right, now here's a more complex Venn diagram, the kind that most of you have probably been familiar with, that has the 3 circles. And I'm just thinking about this. I really think that I would be better off to do this in class with you tomorrow. So what I want you to do, I want you to take a stab at this, and I'm not going to fill it in on this video. I'm actually going to explain it to you tomorrow. And well, I'll fill in the numbers and I just won't talk about it. I'll talk about it in class tomorrow. So I got to label my circles. Football, I got basketball, and I've got hockey. Okay, and what I want to do is I want to highlight the and. The intersection of all 3 of these sports would be this little area right here. This is the and. So the place you want to start when you're doing these 3 circle Venn diagrams is look for the people who do all 3 of those things. Or look for the people, let's see, they said they watch football. 15, here we go. 15 people said they watch all 3 of these. So this is where my 15 is going to go. That's always where you want to start. Or I could start here with the 8 people who said they don't watch any. And these 8 people are going to go right down here. They don't watch any. 15 watch all 3, so I'm going to put the 15 right there. Okay, now I can't necessarily just go down the list and fill in these numbers in the order in which they're presented. For instance, 20 said they watch basketball and hockey. Well, I think I can do this one. 20. So 20 watch basketball and hockey. So basketball and hockey, remember, is the part that's covered by basketball and hockey. So that's going to be this little area right here. That little area that I just colored blue there, that's basketball and hockey. So if I've got 20 people who said they do that, well, I've already got 15 of them right here. So that means there are 5 left to go right there. I guess I am going ahead and explaining this as much as I was going to try to stop myself. But don't worry. If you don't understand this, we have many more that we're going to go over in class next time. So no worries. We'll just go ahead and power through this one. Okay, how about 23 said they watch only basketball and football. Only basketball and football. That should really say they watch only only basketball and football. Well, I'm going to take a red pen here and I'm going to draw around where basketball and football are. Here's basketball and football, right? Basketball and football, right here. Basketball and football. 23 said they only watch basketball and football. They watch only, it's very important that we get these words correct. They watch only basketball and football. So I have to leave out this 15, right? If they watch only basketball and football, I can't include this little part, the people who watch hockey, so the 23 has to go right here. They watch only basketball and football. So that 23's got to go right there because I got to leave out the people who watch hockey. All right, what's next? 25 said they watch football and hockey. So I'll use a green. I'll use a green for that. So 25 watch football and hockey. Get that out of the way. So where's football and hockey? Football and hockey would be right here. Going around football and hockey in green. Everybody with me? Okay. And it doesn't say that they don't watch basketball too. So this whole section here, this little area and this little area have to add up to 25. So that means I got 10 people here, because I got 25 altogether who watch football and hockey. So this area here has to add up to 25. All right. 35 said they watch basketball but not hockey. Basketball but not hockey. So let's see. 35, they watch basketball but not hockey. So I'm trying to think of a different color. So let me use this. Okay, here's basketball, this area here that I'm doing in purple. Okay, this is basketball and hockey, right? This is basketball and hockey. But I got 35 people who watch basketball but not hockey. So I already got 23 of those right here. 23 of those represented here. So 35 minus 23 gives me 12. 12 who watch basketball and not hockey. Because remember, it doesn't say that they don't watch football, so they could be watching football too, just not hockey. All right? So now I'm really getting somewhere. I've got 75 now who say they watch football. So all I got to do now, my football circle, every number in there has to add up to 75. So what do I got 25 and 23. So that's 48. I need 75. So I believe that gives me 20 people who watch football and football only. So 27, maybe I said 25, but since 75 watch football, all those numbers inside the football circle have to add up to 75. And that means I got 27 who watch nothing but football, who watch only football. That's what that tells me. Okay, and then finally I have 44 who said they watch football or hockey, but not basketball. So let me see if I can find a good way to highlight that. Football or hockey. Now, or, you got to know or means union, right? Union. And if I'm looking at a Venn diagram and talking about union, that means the two put together. So football or hockey, I'm going to draw a blue circle around them. Football or hockey would be everything in both of these circles. Football or hockey, but not basketball. And then I got to get rid of the basketball that's contained in those two circles. So now that I've got these numbers here, I'm really going to make a mess of this, but I'm just going to X out all the basketballs contained within these two circles. So that doesn't count, that doesn't count, that doesn't count. So now what I have circled in blue is football or hockey, but not basketball, and that has to add up to 44. So I've got 27 plus 10, 37, so that means I got 7 people right there who watch only hockey. All right, so that's how I go about filling in a Venn diagram like that. And then that's not even the question. What is the question? The question is, how many sports fans did I poll? Because if you look here, a group of sports fans were asked, what sports do they like? How many did I poll? Well, I have to add up all the numbers inside of my circles, and then I have to add the 8. Don't forget to add the 8 people who don't watch anything. And when you add all that up, you get 107 people. 107 fans were polled, and now we know who watches what. Be sure to write yourself a summary. Look back over these Venn diagrams, and I promise you, do not fear if you are a little bit confused. We have much practice to do in this area in class next time.